geometry. We are going over CO9, which is our second objective on shapes. But we get a little more into the weeds here. You know, you'll walk down the elementary hallway, you'll see them hang up their pictures of triangles. You'll hear them recite their shapes with joy from the classrooms. But you don't hear them talking about stuff like convex or concave or n-gons, right? So we're going a little bit deeper, one step up from kindergarten, really, in our study of shapes today. So our objective is to identify and draw regular, convex, and concave polygons using, and this is important, correct labeling. Okay, we saw some issues in previous objectives where we thought something was an angle bisector, but it wasn't labeled as such, so even though it looked like it might be, we couldn't assume it was because it didn't have the labeling. Labeling comes in very, very prominently in geometry. But first, regular polygon. What is a regular polygon? Anybody know? Peter.
Polygon that is regular?
Yes. Yup.
Wow.
A polygon is regular. More specifically, we're all going to learn something new today. These days are fun. Gino? That's a pentagon. Okay. A regular polygon is a polygon with congruent sides and angles. A polygon with congruent sides and angles. So if I asked you to draw a regular triangle, what type of triangle would you be drawing? A regular triangle. Drake? An equilateral triangle, right? Because there's scalene, there's isosceles, right? But an equilateral triangle.
You seem like an equal. Right angle.
Okay, folks, all sides are congruent, all angles are congruent. That would be a regular triangle. If I asked you for a regular quadrilateral, what is the only regular quadrilateral? Do you know? A square. Okay, all sides are congruent, all angles are right angles, so they're all congruent as well. Right? So a regular polygon is all sides, all angles are congruent. Yeah. A rectangle is a square is a rectangle, but a rectangle is not a square. Yeah. Rectangle is not the answer. No, square. 36?
What? It's a math fact.
Oh.
What?
Oh.
Okay, gotcha. Convex and concave polygons.
Like so smart.
Do you know what? Have you heard of the phrase convex or concave before? Joyce?
Convex is kind of like it bulges out, while concave it has water.
No. Joyce close with like the bulging out versus bulging in example, but James?
Convex, like it's like facing out, and concave is in.
Okay, so that relationship of out and in is definitely there. And kind of mathematically, what we mean by a convex polygon is a polygon with segments that, if extended, stay outside the polygon. A convex polygon is a polygon with segments that, if extended, stay outside the polygon. Again, a polygon with segments that, if extended, stay outside the polygon. So let's look at a convex pentagon here. Okay, a convex pentagon might look like this, right? Because if I were to extend any of these segment sides, they all stay outside of the polygon, right? The bottom one, extend that, doesn't go inside the polygon. That doesn't go inside the polygon. That stays outside, right? If I extend all these segments, none of them go inside the figure. They all stay on the outside. Convex. Yeah.
Wouldn't like the normal won't the normal pentagon at the bottom of this page be one too?
Yes. Yes, that would be one as well. In fact, any regular polygon, it will have to be a convex polygon. Okay. Concave polygon, can you guess?
The opposite.
Yeah, kind of the opposite. A polygon with segments that if extended, pass inside the polygon. A polygon with segments that, if extended, pass inside the polygon. So if we look at another type of pentagon, one like this, perhaps, where that top triangle is going inside versus going outward, like the other one is. Notice that, I mean, if we extend this segment here, it passes through the pentagon. That would be a concave, right? Who can think of a good way to remember the difference between convex and concave? If this is the first time you're seeing these terms and you want a little trick to help you, Peter?
Like a concave polygon is like a cave.
Yeah.
Inside.
Goes inside, right? Concave, you go inside a cave, and so do the segments, or the side segments. Questions on this? Cool. Who went home and studied their postulates and definitions and properties over the weekend in anticipation that I might give you a pop quiz today for realsies after last week's farce? No?
It was Friday.
No? Okay. Well, we'll see where the day takes us. Draw and label each of the following a regular octagon, convex pentagon, concave decagon, and a regular convex hexagon. Okay? I'm going to give you about 3 minutes to do this, maybe less than that, then have you come up and draw them on the board. Some better artists up here perhaps than me. So we'll pause it and we'll come back to it shortly. Okay, and we're back. Who would like to venture on up and draw us your very best regular octagon? Several. This is good. We'll have a couple. So don't take up the entire space. Gino, you can start us off. You can pick whichever color you would like to use. A regular octagon.
Or a circle.
I don't think Gino can reach.
Planning it out.
That's
I don't like
Convex pentagon.
Yeah.
Good, Steve.
That's what I wanted to do.
How do you not know what
Whoa. That was his example. That's not
Whoa.
No,
Great.
Proud of you.
like a 3D.
Mackie, can you do a regular octagon?
Yes.
Oh, wait.
Okay.
Do you know how many sides
Yeah,
does
it's
the triangle
red.
have?
Oh boy.
Oh.
Hey, no, it looks beautiful.
Yeah.
Mackie, I did bold in the directions here. It says draw and label. How am I supposed to know that's a regular octagon?
My hand was a little shaky.
Can you come up and label this so that I would know it's a regular octagon?
Just draw like
right
No.
just draw like
How do you label sides to be congruent?
Draw octagon below it spelled wrong.
There you go. All right. So on the test, when I have you draw this stuff, folks, on the test, when I have you draw this stuff, you don't need label because yours is
add
on the
ticks on it.
Even if your artwork is subpar, you can still tell me it's a regular octagon by labeling. Okay, because as we know, things are not always drawn to scale, and so you do need the tick marks in the sides and those arcs in the angles to tell me that is a regular octagon. So if you just drew one that looks like an octagon and look all the same, you need the labeling. Okay, you need the labeling. We don't need labeling here because clearly this is a pentagon, right? I mean, it's just plain as day. But also, there's nothing with sides or with angles to make it convex, right? We can count the sides. We can see it's got 5, and so we're good to go there. Concave decagon. Concave decagon.
I would like to take a
Gino has a question.
Let's let him admire others. You have a question? What's your question?
No, Gino has.
Oh, Peter. Concave decagon.
Peter.
The bar has been set high, Peter.
I know it's better than mine.
Come on, draw the Mona Lisa.
The Mona Lisa is not a polygon.
We can make it a
Well, yeah, you could.
It's the Tesla logo.
Yeah, I got it.
Tesla.
Is that what you went for?
All right.
No, I got better.
Yeah.
So we got 1, 2, 3, 4, 5, 6,
It doesn't-
7, 8, 9, and 10. Those are not congruency markers. That's just how I count the sides. So just for that, there you go.
Hey, can we get some
I only have 9.
What's that? For what? The concave decagon? Or Caleb, do you have a good concave decagon?
I did. I
Doubt
did.
it.
Concave.
Dude, you
Can I
literally
try?
copied
Yeah.
my name.
No, I didn't know. Convex.
What do you do? Good ones.
Let's see. Wait, we're
He's
not
doing the
done.
concave. You can
Where do
just
you
put it
think you
below.
draw?
Caleb, where are you drawing?
Oh, okay. He's not doing that. He's
Oh,
not.
that's not even what you did. Oh,
It has to be a regular one.
And you said
That's
you're
not
wrong.
regular.
He's
That's
wrong.
not regular, Caleb.
What he does is
Caleb, that's not regular.
9.
Eight for this one, right?
Yeah, concave.
I counted 9.
Oh.
1, 2, 3, 4, 5, 6, 7, 8, 9.
You were stupid.
I thought he was doing a regular hexagon.
Attaboy.
Yeah. This would be a concave nonagon, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Mackie.
Can you draw a concave hexagon? Regular.
No.
I'll do it.
I
can't
do it.
Because in order for it to be a, so this is a good question. So why can't a regular polygon be concave? Think about the definition of a regular polygon and then the concavity. Why can't you have a regular concave figure? Like,
Because it has to be all regular and how it's an angle and to make it concave. One is going to be short and then one is going to be.
yeah, I mean when you get that concavity, like I could draw a well, we did the here. Let's do the concave pentagon here. I can make all these side lengths the same. 1, 2, 3. Those are going to be about the same, right? I can do that congruent sides, close enough. But this angle here, the fact that it goes inside the shape, that's going to be the problem, right? You can't get that congruent angle piece. So no, I'm unable to draw a regular concave hexagon. Can anyone draw a regular convex hexagon? A convexagon, some might say. Joey,
Let's go.
regular convexagon.
Munene. Make me proud, Munene. Let's go, Munene. Yup.
1,
Yup.
2,
Yup.
3.
Yup.
No, it's just that hard to draw this
Oh,
thing.
why
Matt's
is
that
it?
for me now, right? Like,
Where are you
some
going?
of this
Keep
is every game.
your keep the marker on the board. I count
I'm
1 6.
trying to.
I count 1 6, Munene. It's not a close figure.
Okay? So
Label it.
how are you showing it? That's what I deal with every day. That I just
How do you do this, Mr. Schultz?
it takes hours after school to practice.
I'm trying to get.
I think it's a concave now. Your line is
I'm really trying. All right. Hey, that's a hexagon.
What are we missing here, James? What do we have to add to this to make it a labeled regular? Yeah,
You left me 80.
the congruent sides also. Okay.
You left me 80.
Thomas, go on.
All right, folks. 3, 2, 1. You are quiet. The bottom section, classify each polygon by its number of sides and whether it is concave, convex, or regular. Who's got the answer to the first one? Drake. Concave what?
Concave, 7 degrees.
Heptagon.
Heptagon.
If you want to say septagon,
7.
that's okay. Okay, but it's a 7-sided figure, so concave, hepta, or septa is concave because if it were to extend, one of the sides, it passes inside the polygon. Next one, Blake. Oh, hold on, phone call. Let's see what we got.
What do you mean it cannot
Yellow.
be regular and convex?
Okay. Correct. Yes. He already let me know that he was, so they may know, but an email home. Gotcha. Yes, I believe so. Yeah, that should be fine. Yeah, fine. Okay. Next one. What do we got? Yes.
A regular convex pentagon.
A regular convex pentagon. Okay. Why are we shocked at that?
Because
You can get 2.
Did I say Blake?
Yeah, and then you went to.
Oh, really?
It's okay, we can just call him Peter.
Sorry.
They're basically the same.
My fault.
No.
Becky.
Okay, look,
You remember that one time when you faked calling my mom in math class?
Yeah,
No, you actually didn't call her.
you are correct.
Yeah, Becky.
Yeah.
How long did it take you to realize that I didn't actually call her?
Because I asked her, and she said she never got a call.
Did she think it was pretty funny though that I had to go in? Next time, it'll be real. Yes, Drake.
Because it doesn't have the congruent marks.
So Drake is Joe. Drake brings up a valid point here. He's saying, well, how can we be sure it's regular without those congruency markers on the sides? The fact that all these angles are equal, by definition, the sides have to be equal as well. So I'm requiring you to put both of them on there because I want you to really understand the relationship there. But if all angles are in a pentagon, all sides are as well. You have to be a little careful because like in a rectangle, all sides are congruent, but obviously that's not regular there, right? So, but in a pentagon, if all angles are congruent, all sides will be also. Okay? But valid point. Thanks for bringing that up. And last one, what do we got there? Yes.
It is a convex
A
pentagon.
convex pentagon. Convex. Your homework for tomorrow.
Is it not Caleb?
7th grade algebra won the number game for the 3rd time today, so they can treat.
They had 3 number games in
Well, I'll try. I am.
Wait, how many do we have?
There's a no.
Maybe they'll share donuts.
Yeah,
do you have any extra donuts? Guys, it's so easy. Just get your homework and cut everything.
On page 45. On page. Actually, let's go.
No homework?
Yeah, no homework.
It's a good idea.
Let's go quiz tomorrow instead.
Let's go page 45. On page 45. 8 through 13.
Oh, there's more.
And
Of course there's more. 13 through 14.
18 through 23.
Oh, there's more.
Oh, there's more.
Haven't decided yet. Hey, folks, James.
If you don't give us more, then
And 40. Number 40. 40 is a multi-step. It's A through C. That's kind of your challenge question there. All right? Homework to tomorrow. That's how you math.
Don't